Welcome to The Explainer. Today we're tackling a project that every single one of you is going to build at some point, but one that, honestly, far too many engineers actually engineer quite poorly: your resume. Think about it for a second. Building a standout resume is exactly like designing a highly optimized mechanical system. It needs a very clear function, it's got strict constraints, and every single component has to work together seamlessly to achieve your desired outcome. If there's a weak link, the whole system fails inspection. So let's dive right into the source material from SNJB's College of Engineering and figure out exactly how to construct a document that actually gets your foot in the door.
Here is our engineering blueprint for today. 1. The purpose of your resume. 2. Core resume components. 3. Categorizing technical proficiencies. 4. Showcasing high-impact projects. And 5. Avoiding those major resume pitfalls.
All right, Section 1, the purpose of your resume. It seems like an incredibly obvious question, right? Like, why do we even need a resume? But this is actually a fundamental concept that so many highly intelligent, highly capable engineers get completely wrong right out of the gate. A surprising number of people treat their resume like it's this exhaustive 10-page technical manual of their entire life.
But here is the crucial takeaway. Your resume exists solely to get an interview, not to get you the job directly. We really need to break that misconception. You don't get hired based purely on a piece of paper. Your resume is a professional marketing document. Its one and only function is to interest the employer enough to make them pick up the phone and call you. It opens doors. It doesn't close the final deal.
And here is the ultimate design constraint you're working against: 10 to 20 seconds. This right here brilliantly illustrates the massive urgency of the situation. You literally only have a 10 to 20 second window to give an employer a positive first impression. In that tiny fraction of a minute, your document needs to just scream capability, organization, and quality. If your layout is cluttered or your key skills are buried, the hiring manager is just going to move right on to the next applicant in the stack.
Moving on to Section 2, Core Resume Components.
Okay, think of these as the absolute non-negotiable structural components that every engineering resume has to have to pass a basic initial inspection. Step 1 is your heading. We're talking clean, clear contact info. Step 2 is a highly targeted job objective or profile summary. Step 3 covers your work experience and education, laid out chronologically. And Step 4 highlights your skills and abilities. This is the standard expected baseline. Missing any of these? Well, it's kind of like forgetting to put wheels on a car design. It's just not going anywhere.
Section 3, categorizing technical proficiencies.
Now, when you list out your software and tools, please don't just dump them into a massive, comma-separated paragraph. Notice the visual organization here. Categorize them. Group your technical skills logically into buckets. Put CAD software together, like SolidWorks, AutoCAD, CATIA. Put ANSYS and HyperMesh under simulation. Group CNC and GD&T under manufacturing, and things like Python or MATLAB under programming. Presenting it this way makes it infinitely easier for a recruiter to instantly digest your exact capabilities during that ruthless 10-second scan.
And taking that just a step further, look at how you can actually validate those categories. Adding specific formal certifications proves your skills aren't just theoretical concepts you skimmed over in a textbook once. Showing that you've got a Six Sigma Yellow Belt, or you're a certified SolidWorks associate, or you've completed an NPTEL manufacturing process course, that gives concrete, undeniable proof of your capabilities.
This extra layer of validation is absolutely vital. As the source material points out, certifications validate your skills, enhance your resume, and give you a competitive edge. Think about it. When a hiring manager is looking at two junior engineers from the exact same university with the exact same degree, the one who actually took the initiative to get professionally certified is going to win that interview every single time. It just shows real dedication to continuous learning.
Let's jump into Section 4, showcasing high-impact projects.
Good projects demonstrate your skills, your knowledge, and your hands-on problem-solving ability, but you have to format them correctly for them to hit home. Every single academic or personal project on your resume needs to clearly display these 5 specific elements: a clear project title, the objective or aim of the project, the exact software or tools you used, your specific role and responsibilities, and finally, the outcome.
Let's look at a brilliant example of this in action. Here we have a project titled Design and Analysis of a Multi-Plate Clutch. The objective is crystal clear. The software, SolidWorks and ANSYS, is listed out. The role is defined, but I really want to guide your eyes right down to that highly effective outcomes section at the bottom.
This right here is exactly what hiring managers are hunting for. reduced weight by 12%. Quantifying your results with hard numbers rather than just vaguely stating what you did is the absolute gold standard in engineering resumes. In the professional world, engineering is all about optimizing systems to save money, increase safety, or improve efficiency. Having hard numbers proves you truly understand that professional mindset.
And here is another stellar example that brilliantly illustrates the concept. For this hydraulic scissor lift project, the applicant didn't just say they designed a lift. No, they explicitly stated that they performed stress analysis using ANSYS to achieve a factor of safety greater than 2.5, while simultaneously reducing component weight by approximately 12%. Combining safety factors with weight reduction shows true engineering optimization. It proves you understand the delicate balance between structural integrity and material cost.
Finally, Section 5. Avoid these resume pitfalls.
Okay, so we've built a fantastic structure. But before we ship this thing out, we need to shift into the quality assurance phase. We need to look at presentation errors that lead to instant rejection. The first massive pitfall? A lack of focus. Contrast a sharp, highly targeted approach against a resume with an ambiguous, vague objective statement. An objective that just says, seeking a challenging position to utilize my skills, literally means nothing to a recruiter. You must focus on the employer's needs, not yours. Your objective and your whole document, really, should be strictly targeted to the specific position you are applying for. Highlight your relevant strengths and de-emphasize any weaknesses.
Let's rapid-fire some critical, visual, and functional don'ts that act as instant red flags to a hiring manager. First, do not title your document resume. They know what it is. Start with your name. Second, for junior engineers, do not go over one page. Shorter is almost always better. Be concise. Third, never use personal pronouns like I, my, or me. Keep it strictly third-person professional. Fourth, skip the fancy fonts and colorful paper. You want uniformity. Making your resume look like a restaurant menu is not the move. And lastly, don't include the phrase references available upon request. That's totally assumed. If they want them, they'll ask. Save that incredibly valuable page space for your hard metrics.
So, as we wrap up this explainer, I want to leave you with a pretty provocative question to ask yourself as you go to redesign your own document. Does your resume truly depict your professional capabilities, or is it just a messy history of your coursework? Remember, your resume is a true depiction of your personality, how organized you are, and your personal sense of quality. It represents you in that crucial 10-second window. Treat it with the exact same rigorous design, analysis, and optimization standards you would apply to any mechanical system. Good luck building, and thanks for joining this explainer.